Good morning, everyone. I'm Alessandro Bagnini, Product Manager of BTS. Welcome to this appointment with a new webinar of GWalk dedicated to the JUMPs protocol. As always, before going into the details of the practical test, I would like to give you a brief overview to understand the importance that the test plays in the evaluation of the athletes. The athlete's assessment is essential in the sport medicine and for trainers, who aim to maximize the performance of the athletes from one side, and at the same time safeguarding the athlete's physical health. So the development of individual training program made possible to minimize the risk of lesion and injuries, and in case of an injuries, for example, to monitor the return to sport process, to define training programs, to set targets and goals, and to monitor the achievement of the results, and to provide athletes with objective data to motivate and encourage them. For a complete functional assessment, the subject is therefore essential to investigate the evaluation of the physiological and functional parameters. We already seen in the previous webinar dedicated to the gait analysis protocol of the GWalk the importance of the biomechanical evaluation. For those who have not seen the webinar, you can find it on the BTS page www.btsbyengineering.com. Today, we will investigate instead the functional vertical jump test. But why the vertical jump? This test is commonly used to evaluate athletes in sports such as basketball, baseball, because the vertical jump, single or multiple jump, allow you to obtain valuable information of the muscle strength, aerobic capacity, and reactivity. So, when we talk about jump test, we need to keep in mind that there are different types of jump. And in this context, one of the most famous test batteries is the Bosco test. The Bosco test is a battery of 6 jump tests: the counter movement jump, single or multiple, the squat jump with arm thrust, the squat jump with balance wheel, drop jump, and stiffness test. Now, I will not go in detail to every single test right now. We will see it later. But now I want to focus on the instrumentation that is used to evaluate the jump performance. Jumps can be evaluated using different measurement tools. For example, the most common entry-level tool is a meter. With a meter, we can evaluate the height of the jump. But then we have also video analysis software, we have also accelerometer. It is evident that by looking at the graph, we can understand how the increase of the refinement of the used technologies increase the number of parameters you can obtain and increase the accuracy of the measure. Today, we will go deep into the jump evaluation using an Excel sensor. But without losing time, I think that the most effective way to understand what is this kind of analysis and how parameter analysis can provide, let's perform a practical session. To perform the practical session, I ask my colleague Andrea to help me. The first thing when we start to perform the test is to place the sensor in a proper way. The sensor must be positioned below the line connecting the two dimples of Venus. It must be inserted inside the belt, and then the belt must be firmly tight. Once I turn on the sensor, I can connect the sensor to the software, which is named G Studio. You can see it by using this button. The sensor connects to the software via Bluetooth. Now, when the connection icon becomes green, the sensor is connected and we can start performing the analysis. So I select, then it is necessary, obvious, to insert the patient. I already prepare a patient that is BTS test. And once I select the patient, I can select the desired protocol analysis. So let's select the jumps protocol. We can immediately see that the software allows evaluation of different jumps. The Bosco jump, counter movement test, squat jump, and so on. Now, let's perform a counter movement jump. Let's click to new jump, go into the acquisition screen. Then I ask to Andrea to stay firm without move for a few seconds. So don't move. And now to jump. Okay, as we can see, the software automatically computes the jump height and other parameters. Now, for demo purpose, we only perform one jumps, but I already prepared some reports to comment with more than one test, so we can go deep into every single jump. So let's start from the counter movement jump that we see just a second ago. In this kind of jump, the jump action is achieved thanks to the strength shortening cycle. So this test aims to investigate the explosive force and power of the lower legs. In fact, this parameter represents an important component in many sports, for example, in volleyball, rugby, who require a high explosive strength. Usually, the jump performance is evaluated measuring the height of the jump, but as we can see, the G-walk gives us a very useful parameters for characterizing the jump. For example, providing in an automatic way the force at the takeoff and impact, the maximum concentric power, the takeoff speed and the impact speed, and others. Another jumps we can perform is the squat jump. In the squat jump, the subject begins the test in standing position with the hands on the hips. Then once the operator gives the start command, the subject starts to perform a squat by bending their knees by 90 degrees and maintains this position for a few seconds. Then from a static position, the subject performs a vertical jump without counter movement. In this jump, the absence of the counter movement allows to evaluate the rapid force, that is the capacity of the neuromuscular system to overcome a resistance with high contraction capacities. Also in this case, the sensor gives us automatically information of force and power, of course, and automatically compute by comparing the squat jump and the counter movement jump an index named elasticity index. This index evaluates the ability to store elastic energy during the counter movement phase of the CMJ, the counter movement jump. In fact, The strength shortening cycle of the counter movement jump allows the muscles to create a more contractile energy and therefore to increase the jump height of about 10% compared to the squat jump. The value of elasticity index, however, are strongly dependent on the time of the sport and therefore show different reference value. Another jump we can evaluate is the counter movement with the arm thrust. In this kind of jump, the correct use of the arm implies a more rapid contraction of the muscles of the lower limb, increasing the height of the jump itself. Optimizing the use of the arm, therefore, means maximizing the jump performance. The contribution of arms during the jump is evaluated by the coordination index, which in the athletes is normal 20–25%. Another interesting application of the vertical jumps concerns the evaluation of the characteristic of the metabolic process in a repeated counter movement of short and long duration. In the repeated counter movement of short duration, we evaluate that is about 15 seconds, a 15-second repeated counter movement. We evaluate the lacticity capacity that corresponds to the ability to overcome a resistance with a fast contraction. This parameter is evaluated using the endurance index. If this index tends to 1, the subject expresses high level of explosive fast force. In the repeated counter movement jump, but of long duration, 30–60 seconds, we usually evaluate the anaerobic lacticity resistance. So we evaluate that is strictly related to the fatigue phenomenon. In this case, we use the endurance index, and if this index is around 1, the subject has a good resistance to fatigue. Then we can also evaluate different jump, other jump, for example, the squat jump with body weight. Usually in the Bosco test, the weight is more or less equal to the body weight. The drop jump, who is useful for investigate the reactive explosive force, and finally the stiffness test. The stiffness test is a test who allow to evaluate the reactivity of the athletes, because the athletes have to perform a first counter movement jump and then a very fast jump, minimizing the impact time. Is therefore, I hope, clear from my explanation that using the sensor for assess the jump, we can obtain a wide range of information who are useful in evaluate the athletes, in prevent the injuries and monitor the situation of the athlete itself, in define training program, and in provide an immediate feedback to the athletes, and then to motivate them. Now I finish my presentation. I really hope you like it, and I want to thank you for your attention. Thank you and see you soon. Bye.